A few more problems to give you as examples on day two. First, a particle is moving along the graph of the function y times x plus 1 equals 1, such that dx dt equals 2 centimeters per second when x equals 3. Find dy dt. So if we have y times x plus 1 equals 1, this is something that we would use implicit differentiation on, and this has a product rule. So the derivative of y is dy dt. Um, and since we're taking the derivative with respect to time, since the particle's moving, then it's going to be with respect to t. So times x plus 1 plus the derivative of x plus 1 is just dx dt. So we have y dx dt equals 0 since the derivative of any constant is 0. Now I have some information. Dx dt is 2 centimeters per second when x equals 3. So that means that I can substitute 2 in for dx dt, and I can substitute 3 in for x, so I can make this 3 plus 1, which is 4. I still need to find dy dt in this problem. The only thing that I'm missing is what y is. You can figure out y, since I know that x equals 3. I will take x equals 3 and plug it in, so 3 plus 1 is 4. Divide by 4, I get y equals 1/4. So in this particular case, y equals 1/4. I now just do some solving. So 4 dy dt plus 1/2 equals 0. So I subtract 1/2 and divide by 4. Dy dt equals negative 1/8 centimeters per second. That's how fast y is changing, and it also gives a direction that y is changing. Y is moving down. Problem 2. Oil is leaking from a pipeline on the surface of a lake and forms an oil slick whose volume increases at a constant rate of 3,000 centimeters or cubic centimeters per minute. You can kind of read the rest of this problem. There's a cylinder, and it's going to be a really wide cylinder that's not very tall, at least at the beginning. And that's kind of what an oil slick would look like on the top of a water or on the top of the ocean or a lake or something. And so we have a radius and we have a height. And in this problem, it gives us some information. So it gives us the rate of change of the volume with respect to time. That's 3,000 centimeters cubed per minute. The radius is 80 centimeters at a particular time, and the height is 1/2 of a centimeter. So all of this is information that they give us at the beginning of the problem. At this exact moment, so when these two things are happening that I have boxed in red, the other piece of information that we have at that moment is that dr dt is 2 centimeters per minute. So we have all that information, but notice that all of these things are changing constantly, so I can't substitute anything in before I take the derivative. So now what I'm going to do is I'm going to write down the formula for the volume of a right cylinder, um, and that is pi r squared h, which they were very nice to give you in this problem, but that is not something that happens on the AP test typically, so you do have to know your formulas. I'm going to take the derivative with respect to time, so dv dt equals 2 pi r h dr dt plus pi r squared dh dt. So I just had to use the product rule with implicit differentiation, and now I do a bunch of substituting. So dv dt is 3,000 cubic centimeters per minute. I'm actually not going to write down the units to make my life a little bit easier. Now I have 2 pi, r is 80, h is 1/2, dr dt is 2, plus pi times 80 squared times dh dt. And we can multiply everything together. This part ends up being 160 pi, and then we would subtract that over, 80 squared is 6,400. So when I subtract over the 160 pi and I divide by 6,400 pi, this would be my final answer. So that's dH dt. If I wanted a numerical value for that, I could type it in the calculator, make sure that you round or truncate to 3 decimal places, because this is an AP calculus class and that's what they require. So dH dt is 0.124 centimeters per minute. Remember, round or truncate to 3 decimal places. So that's part A. Part B, we're going to find the rate of change of the surface of the oil slick. So the surface area of a circle is pi r squared. We take the derivative, so dA dt, which is what we're trying to find in this problem, is 2 pi r dr dt. And at this exact moment, once again, they've given us both of these pieces of information that I can substitute in. So 2 pi times 80 times 2. I probably should move this over just a little bit, so then it's a little bit easier for you to read. And then when I just multiply everything together, I end up with 320. That's not a 2. 320 pi, which you can leave the answer as, or you can also write it as 1006.310 centimeters squared per second is the rate of change of area with respect to time. Once again, even though it's 0.310, you have to put the 0. You have to leave 3 decimal places, since this is rounding or truncating to 3 decimal places. If you don't put the 0, they don't know that you're actually rounding or truncating to the correct spot, and they will mark it wrong for you. Now, if the answer was just 0.31 and it was um, the decimal stopped, you wouldn't have to put the 0. But since we're rounding or truncating, we do have to put the 0. Problem 3. In this problem, I want you to read it. You can see that the radius is 5 inches and it's not changing. So it's not like this is a cylinder that's increasing like in the oil slick problem. So that means R equals 5 is constant. And I am allowed to sub in 5 before taking the derivative. And that is very nice and saves a lot of problems when I am allowed to do that, which I am in this problem. So the volume of a cylinder is pi r squared h. I'm going to sub in 5 for r. 5 squared is 25. So I have 25 times pi times h. Now I'm going to take the derivative. So dv dt equals 25 pi dh dt. Then I note that the problem tells me that dv dt is negative 5 pi root h. So when I continue with this problem, I end up dividing by 25 pi. So I have dh dt equals negative 5 pi root h over 25 pi. And then I can do a little bit of simplifying. So dh dt equals negative root h over 5, which is exactly what the problem told me it would be. Anytime the problem tells you what the answer is before you start, you have to make sure that you do a very good job of showing your work and showing all of your steps, because they're assuming that you know the answer since they told it to you. So you have to make sure that you show all of your work and show them that you know what you're talking about.